Welcome to Klein's Geometry. Today we're going to talk about Glendon lesson 3-6, perpendiculars and distance. Our new skills are going to be how to find the shortest distance between a point and a line, and how to find the shortest distance between two parallel lines. You have learned how to show two lines are parallel using angle relationships. You know that corresponding angles are congruent, alternate interior, alternate exterior, and that's it. Are all congruent, and if that's true, lines are parallel. You also know that if you've got same side consecutive interior or same side consecutive exterior angles, those are supplementary. So you can show lines are parallel. Well, if you know they're parallel, we want to be able to find the distance between either a point and a line or between two parallel lines. So that's the goal for this lesson. Our new vocabulary is going to be equidistant, this word. Notice it's a nice combination of equal and distant, and that's exactly what it means. It means if two things are equidistant, maybe from my house to the high school or my house to Myers, those are equidistant, that means they're both the same distance apart. So if you go from a house to a library, house to a bank, if they're the same distance apart, they're equal distance. So let's look at a particular distance. We're going to look at Grandma's house up here. And Grandma has a side door, a little porch here, and she wants to make a sidewalk that takes her to a road. Now, the road, we want to take the shortest distance for this sidewalk. She doesn't want to spend a fortune on it. So, what's the shortest distance? Should we go this way to the road? This way to the road? This way to the road? Looks like we're getting shorter, doesn't it? It turns out, if you draw a perpendicular line from a point to a line, that's the shortest distance. You can tell that's this long. Well, I've got to go bigger here, bigger here. So shortest distance between a line and a point not on that line is always going to be a segment perpendicular to that line through the point. And we need to find out what is that distance. That's our goal, okay? So, in other words, if you're given a line and a point not on the line, like this one, if you draw a perpendicular through there, that distance is going to be the shortest distance, okay? So, when you look at like a roof truss, you'll see that, okay, we want to put a support from this point to the line. Well, if you want to put a support, that's going to be the shortest distance. You're going to go straight down perpendicular. You aren't going to go over here or over to the side. So shortest distance, perpendicular to the line from the point. So take a look at this kind. Test yourself here. We want to know which segment represents the shortest distance from this point up here, A, to line DB. And you've got A to D, A to B, C to X, or A to X. And I hope you're choosing A to X, from X to A, perpendicular. Nice job. So now we're going to look at how do you find the shortest distance if you're given this line on the coordinate plane with 2 points, 0, 0, negative 5, 5, and the point 1, 5. How am I going to find this distance, this short distance from this point to this line? Well, you can kind of see that it's probably going to come right in here. It's going to be somewhere in here at negative 2, negative 3, somewhere in here. But we're not sure what, and coordinate planes aren't always exactly, you can't accurately do it with a visual. We need to use algebra. So here are the steps we're going to use, okay? Write these down in your notebook, and then we're going to go through them. So just pause the video and write these down. We're going to find the equation of the line S, then find the equation of a line perpendicular to S, solve the system to find that point, and then just use that point and point V to see how long that line is. So pause and write those down. Glad you're back. Now let's find the equation of line S. We know S has line points 0, 0 and negative 5, 5. And then we want to go through the point V, which is 1, 5. So step 1, we need a slope. 5 minus 0, y minus y over x minus x. We end up with 5 over negative 5 equals negative 1. That's the slope of line S. We have a point. We can use either point to write an equation. I use the ones with zeros and ones if I can, easier. So y minus y sub 1, I'm going to use 0, equals the slope times x minus x sub 1. And that's going to simplify to y equals negative x. There's the equation of line S. Easy to do. Step 2, we want the equation of a line perpendicular to S through point 1, 5. So we know our point. It's going to be 1, 5. We know our slope because we know the slope of line S and we take the opposite reciprocal. So the perpendicular slope is going to be a positive 1. So now we'll write this equation. Y minus 5, remember it's the y coordinate, think of this as x sub 1, y sub 1, equals the slope times x minus x sub 1. Simplify that to slope-intercept form. Add 5. And this is a line perpendicular to S through 1, 5. Now, if I found the intersection of these two lines, I would know that point went a little too far for some reason.
It's good. It's still going forward.
Sorry guys, my first day with my new PowerPoint. I would know this point that was coming down here perpendicular to here. If I knew this point, I can use the distance formula. So that's what I'm going for. So I'm going to use substitution. Note that both of these equations equal y. So I can set this, because that equals y, equal to x plus 4, because that equals y. And I can say negative x equals x plus 4. A little algebra, take away x from both sides, and I have negative 2x equals 4. Divide by negative 2, and I've got x equals negative 2. So now I know the x coordinate of that point. I can put y equals negative, and I'll put it in my x coordinate to get 2, or I could use this equation, y equals negative 2 plus 4 equals 2, to get the y coordinate. So either way, my point of intersection is negative 2, 2. Now we are almost there. The last step is to just find the distance, the length of that segment. So I've got a point right here. That's one end of the perpendicular segment. And I've got another point, and I'll use my distance formula. Remember, x minus x quantity squared plus y minus y quantity squared. So I'll put in 1 minus negative 2 squared, and I'll put in 5 minus 2 squared, and I will get, remember, minus a negative is plus, so I've got 3 squared, which is 9. Here I've got 5 minus 2 is 3 squared, which is 9. So I have the square root of 18, which is equal to, well, we can leave it as an exact answer as the square root of 18. We could also call that 9 times 2, square root of 9 is 3, 3 square root of 2. So either one of those answers would give you a nice exact distance from the point to the line. So that's the first big process. Now similar to that is to find the distance between two parallel lines. And realize that, and when you think about theorems, if two lines are equidistant from a third line and they're parallel, then all three of those lines are parallel. So let's look at our distance between the parallel lines. So now again, we just want to find this distance, and it's got to be perpendicular to both of these lines. Now, the easiest way to do that, well, if you're drawing, you can kind of see, if you laid a paper up here, it'd be this distance here, and it's gonna be the same all up and down the line. So what's nice is to find a point that's not a fraction, get a y-intercept here, and let's just find like this distance right here. So, again, we have steps for that, and our steps, first off, it's always good to graph the lines, and just so you see what you're doing. And draw that perpendicular line through one of the intercepts so you know what's going on. And then please write down these steps. Notice they're very similar to what we just did. We're going to find our slopes, and we're given equations here, so that'll be easier. And then we're going to find our perpendicular line and solve it just like what we did earlier. New markers, kind of messy. So the first thing we do, we look slopes of parallel lines, think y equals mx plus b, so m is the slope. So if you think about our steps, we know the parallel lines, the slope is 2, because it's the number being multiplied to x. Slope of any line perpendicular to that, perpendicular line, is going to have a slope, think the opposite reciprocal. So instead of 2 over 1, which is what we have there, we're going to have a negative 1 over 2. That's the slope of the perpendicular line. And then, like I said, we want to take that perpendicular through this line and then find out where it intersects this line. So I see that the y-intercept of this line is 3. So I'm going to write my y-intercept. I have another point that's 0, 3 from line A. That's my y-intercept, 3. Now to find the equation of a line perpendicular to A, through this point, I'm going to use my perpendicular slope, my point, 0, 3, and I'll write the equation. Y minus y sub 1 equals the slope times x minus x sub 1. Y minus 3 equals negative 1/2 x. Add 3 to both sides, and we get y equals, let's do it this way. Add 3 to both sides, that's going to make a 0 here. Y equals negative 1/2 x plus 3. This is perpendicular to the parallel lines. So now if I took this, and I could solve a system with this perpendicular line, and well, we've got to use this one now because we used this to get that, we use the point from this one, so now we have to use this one. So we're going to use y equals 2x minus 1. So my system is y equals 2x minus 1, and y equals negative 1/2 x plus 3. Notice again, they both equal y, so I can set this equal to this. 2x minus 1 equals negative 1/2 x plus 3. Solve the system, get all my x values on one side. I'll add 1/2 to 2. 2 is the same as 4/2, so I'm going to add a half, and I'm going to have, I'll go plus 1/2 x. This will be a 0, and on this side I have 5/2 x. Minus 1 equals 3. Add 1, 5/2 x equals 4. And then remember, when you've got a fraction, multiply by the reciprocal. And a number times its reciprocal equals 1. So I have 1x here, and I have 4 times 2 is 8 over 5. So 8/5 is where the x-coordinate where my line crosses, my perpendicular line crosses y equals 2x minus 1. Now to find my y value, I can plug it into either one of these, substitute it in here. So 2 times 8/5 minus 1 equals 16/5. Put that over 1. Minus, and 1 is the same as 5/5. So 16 minus 5 is 11/5. That would be my y coordinate. If you wanted to